Lymphatic system in your textbook, it's going to be chapter 13. So lymphatic system has multiple functions. So the immune system, it also filters, so all the fluid in your body and all those lymph nodes, all the nodes in your body are part of it. Where's your spleen? You guys remember?
In here.
Right off your stomach on the left side. Right.
Which one bigger, the spleen or the thymus? Is the thymus bigger?
Depends. Because at birth, the thymus is huge. But when you get older, the thymus gets smaller because remember, your immune system gets smarter. So you don't have to make all those generic soldier cells.
So when you ask, like, on material, which part are you talking about?
Comparing those two things, the thymus versus the spleen, that's the question. Which is bigger in a child or an adult?
It didn't say.
This is in general.
Mm-hmm.
I'd go with the spleen.
The spleen?
Yeah, I'd go with the spleen. So edema is that fluid retention. Remember the cardiovascular system, the capillary beds are very leaky. So plasma will leak outside of the blood vessels into the interstitial space. And then return proteins to the blood and the fluid. This is all dumped in your subclavian veins. So that's how the fluid, the plasma that's leaked out, gets back into your cardiovascular system. What are the T cells?
The white blood cells fight infection.
Yeah, so those are your main soldier cells that HIV infect. And then the B cells were, do you guys remember? The B cells, what they do?
Don't they remember?
There you go. They're the memory cells. So they hide out in your lymph nodes, right? They hide out in your lymph nodes because you're filtering the fluids in the body, so they might as well detect any pathogens. Antibodies. That's another word for saying immunoglobulin. So len or anything that ends in in is like a protein. So it's a globular shaped protein that's involved in your immunity. And they're usually Y shape, and the ends is what can detect bacteria or any antigens. So all antibodies are markers. They mark things that are going to get destroyed. All right, your lymphatic system is a one-way street. Everything is collected from the body and it is returned right here under your collarbone in those large veins in your vena cava. So all the fluid that leaks out gets returned. And while it's being returned, all your lymph nodes will filter those fluids, detecting any pathogens that might be there, eliminating them and destroying them. The right branch is actually very small. It only covers this side. The left branch actually covers the rest of the body. Pretty interesting how it is segmented. So here it is diagrammatically, one-way pathway, whereas the cardiovascular system is a loop, right? It's a figure-8 loop going to the lungs and the body. So these are like checkpoints, filtering out any pathogens that might be there because we need to get rid of them before we put it back into the blood supply. Here's just a bigger part of it. So medulla is the middle. Macro is big. Phage is eating. So these are the big cells that eat debris. And then your T cells will fight off anything that's been marked with an antibody. Your B cells right there, they hide out, just detecting, looking out for their specific antigen. If they find it, they'll mark it, and then the T cells will attack it. The thymus, right above the heart. So I said yesterday, in an infant, it's a lot bigger because they have a kind of dumb, non-specific immune system. So they need to make tons and tons of generic soldier cells. So infants, children, they have a really good immune system. It's just not smart. So as you get older and your immune system becomes very specific, you don't have to make as many of those generic cells. So they get a little smaller in adults. Here's your spleen right off your stomach on the left side of your body. It filters out blood cells towards the end of their life stage. Repurpose them. All right, some of the terms. So lymphatic, lymph vessel, and then we talked about the soldier cells and then the memory cells. What's thymucin? Protein from the thymus. How do you spell the word root for spleen? How many E's? Just one, right? So remember, the word has two E's, spleen. The word root is just splen. Adeno we had already. Immuno is easy. Lymph. Lymphaden. So again, kind of like a gland because it produces excretions, in this case cells. Angio is a vessel. In this case it's a lymphatic vessel. And then here, one E for the word root for spleen. All right, we have two terms for red, right? We have eosine, and then we have erythro, right? So in this case, erythrocytes are the red blood cells that carry oxygen, O2. Right? They have hemoglobin, right? Blood protein that carries oxygen. Leukocytes are the white blood cells. So those are the immune cells. And then thrombocytes, thrombo is clot. Those are your platelets. Radiograph. So here they put a radioactive imaging substance in the body, and you can see where the nodes are picked up. Here are the ones in the groin area. Why is the lymphocyte so hairy? What are all these things sticking out? Yeah, so those are surface antigens, and they need to reach out and specifically match up with a potential disease, bacteria, virus, or fungi. So here's HIV, right? Same structure, has a bunch of stuff on its surface, but with HIV, they mutate very quickly. So if you take one drug that recognizes this stuff, next month it might change and start making X's, and your drug doesn't recognize it anymore. So you always have to switch up your HIV meds. Same thing, T cells, B cells, right? They're very hairy-like because they need to extend and they need to match. They really need to match up with the pathogen that they're designed to destroy. So it's very specific. HIV, anywhere there's T cells, because that's where HIV is transmitted. So if you pass about T cells, then you may contract HIV. So if I'm HIV positive and my partner's HIV positive, do we have to use condoms? Do you have to use protection? Safe sex practices?
Well, I would still think so.
Yeah, because remember, my drugs are working for my specific virus. Their drug is working for their specific virus, and they might be different antigens on their surface. And then if we mix them, your drug cocktail is not going to work on all of them, right? Yeah, so the drugs won't work on everyone. So even if both partners are HIV positive, they'll still need to use protection. So blood, contaminated needles have T cells during birth. So the placenta actually blocks out HIV to the child. So the mother, if she's HIV positive and we know about it, it's a big old cesarean section. We lift the child out and we start the kid on HIV meds right away. If we know about it, then the child will never get HIV. And then before they tested for HIV, you could have gotten it through blood transfusion. Let's say you needed a kidney. All right? How easy is it to find a match for a kidney? Very hard, right? So be the match. You guys look for that. But what if there's a kidney, but it's HIV kidney? Are you going to take it?
No. At all.
So if you don't get the kidney, you die in like 3 months, right? But if you get an HIV kidney, we got all these drugs. You ever heard of Magic Johnson? Oh, okay, he has HIV. How is he? How's his health? Smiles, right? He got all those Starbucks in the hood, making money. So nowadays, if it's not very perfect organs, even if it's HIV or hepatitis B, they might still go ahead and transplant because your life with HIV is way better than your life without any kidneys.
It ain't.
Well, you'd be dead if you didn't have kidneys. That's the whole point. Right? So then you just have to deal with it. So in our country, where is the HIV epidemic spreading?
7 states.
Florida. Stay away from Florida. Yeah, if you're from Florida, I'm sorry. No reflection on you, but just stay out of Dago. You cannot get it from anything that does not have T cells, right? You need those infected cells because that's where the HIV is hiding, inside the T cells. So if you're not spreading T cells, you're not spreading HIV. You ever heard of Greg Louganis, the Olympic diver who was HIV positive? He was on the platform and then he hit his head and then a bunch of blood started leaking into the water. He wasn't out yet, so his coaches knew and he knew. Did he tell anybody? Was there a risk? I don't know. Was it ethical?
That's not ethical, but don't it die once it hit the atmosphere and all
Do
that?
we know? I don't know. Did they know at the time? It was like the 80s, 90s. All right, so that's a big issue. You guys want, if you want, research it. Pretty interesting. Greg Louganis, Olympic diver. Allergies. So your immune system is supposed to protect you, but sometimes it goes overboard. It just goes crazy. So a lot of times your allergies is your immune system went overboard. Right? So for you guys, it could be seasonal, right? Pollen, ragweed. Pollen's actually plant sperm. So, so actually you're allergic to pollen. But one way to help reduce allergy symptoms is exposure. So how do you get exposed to pollen? What do you eat? Honey, yeah. Local honey will have different pollen and different antigens from the local plants. So you gotta have local bee and local bee pollen. So on the feet, on the legs of bees, they'll collect pollen. So all you're doing is eating plant sperm, but you're being exposed to it, and then your body goes, hey, it's always around, don't worry about it. So if you're allergic to peanuts and nuts, they have a peanut patch. So it's a dermal patch they put on you, and you slowly get exposed to peanuts, and then you no longer get that anaphylaxis. So what's anaphylaxis? What's ana? Ana means to bring together. So your airway gets swollen and it gets brought together. So you can't get any air in and out. Anaphylaxis. All right, so the immediate reaction. Okay, so what happens is this yellow thing is the bacteria. We'll just call it bacteria. So your big eater here. So what's the big eater called? Macrophage. Macro for big, phage for eating. He eats up the bacteria and he goes, hey, you know what? Look out for this guy. So he puts it on his body and he goes, you know what? That's what you need to look out for. So the first time you experience a bacteria, your body has to tell its friend, hey, look out for this guy. And then this guy goes, okay, I know what out to look for. And it tells him, hey, make antibodies. anytime you see this guy in the future, mark him up. So that's why you see the antibodies here marking up the bacteria. And antibodies are usually dictated like these Y-shaped structures. So that's all your immune response is. So like with the vaccine, so instead of getting exposed the first time naturally, like chickenpox, right? What do parents do? They tell their kids to hang out with a kid who already has chickenpox so they get it. So that's the first exposure. But in a vaccine, we control that first exposure. We stimulate the immune system, but we don't get you sick, right? So this first response here by the macrophage can take a long time. So that's why you get chickenpox the first time. But after a while, the memory cells, right, they're going to watch out for the same chickenpox virus, and if it's in your body, it'll destroy it before it can infect you. So that is the strategy for vaccines. Exposing you without getting you infected, so your body, your immune system remembers it for the next invasion.